want to check the value of an expression, or when you would want to loop and do a particular task. It's always good to understand how you manage flow control in R. That is, either when you're working with your for loops, your while loops, also understanding how you can use your logical operators for working with your data in R. So let's look at some examples and understand logical operations. So either you could be having AND, or you could be doing a OR where you're evaluating one condition, or you're using NOT. So these are your logical operations. Now here I can assign a value to X, and then I can check if my X value is less than 10, and it shows me false. So I have been checking the value of X. So let's see, is it greater than 10? And that's true. Now I can use logical operations here. So I can say AND. So I'm saying, is my X value less than 20? And is my X value greater than 10? Now both these conditions are not true. So in this case, we get the result as false. But if I say X is greater than 20, which is true, and I'm saying X is greater than 5, that's also true, and X is equal to 25. Now, whenever we are talking about AND, we have to look at all the conditions have to be right. So let's look at this, and we get the value as true. But if I say X is greater than 10 or X is greater than 5, then one of the condition has to be true, which is true in our case. So we get the result as true. We can take a different example. We can say, is X less than 20, which is not true, but is X equals to 30, and that's also not true. So in this case, we get the result as false. Now we can straight away compare some numbers, and we can say, is 12 equals 3, and that's false. And if I say not, then that basically will give me the result as true. So these are some simple logical operations which help you when you're working with your data in R. Now we can create a data frame by using an inbuilt data set, empty cars. And let's look at our data frame. So that shows us the values with all the different car models and the different column names. So car models are the row names, and then you have other things like mileage and cylinder and so on, which are the specification for the data. Now what I can do is I can filter out values here using indexing. So I can say data frame. Now in that data frame, I would want to compare the value of mileage, which is greater than or equal to 30, and then I can end it with comma. So that gives me the value wherever the mileage is greater than 30. I can also do a subset on data frame where I can select a particular value. So we can be doing this, or we can be using square brackets. We can also do a dollar and compare the values. Now we will use our logical operations knowledge here. So we will work on data frame where I'm interested in the mileage, which is greater than 20, and I'm looking at the column HP, horsepower, and that should be greater than 100. Remember, when we are doing a AND, both the conditions have to be met as true. And that shows me the result where you're looking at the mileage and you're looking at the horsepower column. Both of these are met, and that's why we get the result. So these are some simple examples of using your logical operations, either when you're working on a data frame. So same thing can be done on a matrix, same thing can be done on a list or a vector or individual values. Now let's also learn about flow control. That is how if else or else if is handled in R. So you can do a single condition check. So for example, I assign a value to hot, which is false, and I'm saying temperature is 50. Now what I would want to check is if the temperature value is greater than 60, which in our case will not be true. Which will not be true because temperature has been assigned 50. So is it greater than 60? No. So if I do this if condition, and I am saying if the condition is true, then I would want to assign the value of hot to true. And now if you look at the value of hot, it is still false. Why? Because the condition which we passed for our if is not true. It has not been met. So whatever was passed within the statement has not been done. Now let's change the value of temperature as 100. And now if we do the same thing, we say, is my temperature greater than 60, which is right. So then whatever has passed in the bracket will be applied. So hot will be assigned new value. And now if you see, the hot value is set to true. So this is a simple single condition check what you're doing. Now certain times there can be multiple conditions to check. And that's where we use else. So in this case, we go for assigning a value to score, which is 63. So let's do that. And now let's say, is my score value greater than 80, which is not true. So whatever is passed in here, which is print, it's a good score, will not be done, but it will jump to else, and then whatever we have passed in else will be done. So it will say it's not a good score. So let's do this if, and it says it's not a good score. So this is a simple way of using if else, where you are checking two conditions, or you are checking the condition, but what if the condition is not met? Then your control is passed to your next statement. Now I can also do a else if. So I can say score is 63, and I can say, is my score greater than 80? That's my first condition. So it would print good score. But might be I would want to check something else. So I'll say else if, and I'll say, is my score greater than 60? Yeah. And is it less than 80? Remember the and, which has to evaluate and true for both the conditions. So I'll say print decent score. I can still keep on giving conditions here in else if. Is score less than 60 and score is greater than 33? That would not meet, so that will be ignored. And then you have else, which says print poor. So first it checks or evaluates for the condition which you have passed for if. If that doesn't work, then it goes to else if, and if anything in else if is met, then it's going to take that into consideration and it will not go for else. If and else if conditions are not met, then it goes to else, and we see decent score already printed here. Now that's a simple example of if, else, and if, else, if, wherein we are evaluating a condition, but probably we have multiple other things to check. Now, how do you work with while loops in R? That's very simple. So what we can do is we can assign a value to X, and now I will say while my X is less than 10. So I'm going to create a loop. So I have said my X has been assigned a value of 0, and that's fine. So this is going to be less than 10. But if we are going to just do this, then it will keep running and it will get into an infinite loop. So we'll see how we do that. So we'll say while X is less than 10, I would want to basically have the value of X. I would want to print X is still less than 10, adding 1 to X. And what we are doing is we are incrementing the value of X. Now, if you do not do this step, then it will get into an infinite loop because X will be always less than 10. So we are incrementing the value of X by 1, and then we are giving a condition. So if at any point of time X is equals to 10, I would want to say X is equal to 10, terminating the loop, and then basically my while loop ends. So we can do this. So let's say X is 0 and then do this while loop, and now you see it is at every step, it is basically printing out the value of X. It is still less than 10, adding 1 to X, and it also gives you the value of X. So when we do a X is currently, and I print out the value of X, so it shows me 0. Next time you increment it, it becomes 1 and 2 and so on. So this is where you are using a while loop, where you are looping where based on a particular condition, and then you basically have, once the condition is met, you are able to complete the loop. Now let's look at, let me take this one here. We'll look into functions in a later stage. So let me take this function and let's get rid of this one. I would also want to talk on break statements and while loop. And once we are done with the flow control on while loops, Then we can look at the functions aspect. Either we can look at how we control our functions or how we create built-in functions. So let's look at this one, and let's continue with our while loop. So we just saw a simple while loop here. And what we also want to see is when you're working with your while loop, how do you break if a particular condition is met? So we saw a simple example of while loop, and that's fine, wherein we were printing out something, we were auto incrementing the value of x. We were also checking at one point of time within our while loop, if the value of x was met, we would say we are terminating the loop and it comes out of that. Now, if that does not happen, then we continue doing it. How about a break statement? So break statement is when you would want to end the while loop if a particular condition is met. So for example, here I assign a value to x, which is 0. Now I want to evaluate this lesser than 5. So that means I will be auto incrementing the value of x. So I'll create my while loop. I'll give in a condition that x is less than 5. Now what I want to do is I want to use the cat function, which will print the value. So I'm saying x is currently, and I am printing out the value of x. Then I say print x is less than 5 because we have not yet incremented the value of x. We are adding 1 to x like what we saw in previous example. I am saying x is then incremented by 1. And here I'm saying if x reaches 5. So while we keep incrementing the values within the while loop, we'll see if x's value is 5, we will print it is equal to 5, and we can just do a break. Now, if you do not use a break, you can still end the while loop, but break is basically to end this loop here based on condition which is met, and we can do this and then run this while loop. So you see here x was met as 5 and we just broke out of the loop. So that's your simple while loops, what we are seeing. Similarly, we can work on for loops. So for loops can also be useful. So your conditionals, what we saw as if else or else if, your while loop is while a condition is not yet met, you keep looping and keep doing some actions. Now what you can do is you can also work on for loops. So here I'm creating a vector and then I am going to loop, that is I'm going to iterate through every element. So I'll say for, and when you're using for loops, you'll say for, and then you can give in anything. You can give in any value. I can say I can say x. So I'm just giving temporary variable in vector and then I'm printing it out. So this basically prints all the values one by one. So there is one more way to do it. You can say for and you can say I in, and I would want to take length of the vector. So 1 to the length of vector, that is till the last element is reached. I would want to print the vector elements using the value of I. So what is I here? It's the index position, and I can do it in this way. So if you are looping over a list, so I'm creating a list and it's very simple. So you can just do a for loop where you can say for I in list, I want to print the I, and that gives me the list elements. Or you say for I in and you give from starting position, that is 1, till the length of list, and you would want to print every element. So here we can also use double brackets. So if you would want to loop through a matrix, so sometimes that might be required. So let's create a matrix which has 1 to 25 values around by row, and you look at your matrix, and now what you want to do is you want to iterate through a matrix. So you want to do a looping. So I'll say for I in matrix, I would want to print out the values, and that prints out all the values in matrix. Now what if I want to print the square and square roots of numbers between 1 to 25? So I can say for I, wherein the value starts with 1, ends with 25, and then within my for loop, I can basically give this condition where I'm saying get me the square root, that is I into I, or get me a square root of I, and just print it out. So I'm saying message I is this one, square root is this, and my square is this, and square root is this. So if I look at this values here, now I am looking at all the values from 1 is to 25. I'm looking at the square of the values, and I'm looking at the square root. So what we did was we did a for. We passed in the elements by saying I in 1 to 25, and within the bracket I have said what do I want to do for every element. So either I've calculated a square, I've calculated a square root, and then I'm printing out when I'm using the message function, which takes the value which you are passing in, comma, the value of I, similarly square, and similarly square root. So these are some simple examples of understanding flow control in R, that is using your for loops, your while loops, and also your if else. Later, we will spend time in learning about functions, which could be either created by the user or built-in functions, and also factors in R. Welcome to this section of R programming, where we will learn about functions, whether that is about inbuilt function or creating your own functions and working on your different data structures. So what are functions? Function is basically a set of statements to perform a specific task. Now, R has a large number of inbuilt functions, or you can say packages, which you can import and start using, or users can create their own functions. So when it comes to functions, the syntax is very simple. You give a function name, you can assign your function to a variable, and a function can take no arguments, one argument, or any number of arguments. So let's see some example on functions. So for example, here we are creating a variable called squares, and we are assigning a function to it. Now this function would take one argument, which is a, and then we use a for loop. So we say for I in from 1 to the number a, we would basically be doing a exponential computation. So what we would do is we would square the value in this particular range and assign that to b and print it. Now when we do this, we can call in this function and pass in a value to look at the square of that particular value. Now this is a simple example of function. So this is how it would look depending on what value you have passed to the function. So for example, we say squares and we pass in a value of 4. So that becomes for I in 1 to 4. So you would start with 1. The value of 1 square would be 1. And then you have your value for 2. So 2 square would be 4. Then we have 3. 3 square would be 9. And then we have 4 square, which is 16. This is a simple example of function. And this is how you can create your own function to calculate or carry out some computations. Now let's look at some other examples before we get into built-in functions, which basically allows you to work with different data structures. So there are different mathematical functions which can be used for your data science or computations. You have your regular expressions which can be used for pattern matching, or you can also use functions for data manipulation. Now, before we get into data manipulation, let's look at how you work with functions, taking some examples. So let me bring up my R Studio, wherein we will try out some examples and see how functions work. Now, here are some examples and we can see how this works. Let me just clean up the console and we can start here. Now here we are creating a simple function which does not take any argument. We call it as hello world, and this will start with the word function and parenthesis. Now that could have arguments passed in. However, this function, we are not passing in any argument. And what we are doing here is we are printing out whatever value is passed within the bracket. So let me just do a control enter. My function is created. and you can straight away call this by just doing this. Now, however, if you would have tried this function without the bracket, for example, something like this, then it would have printed out the complete function. It would have printed out the complete function and whatever you passed in to hello world. But if you would want to call the function, then basically you would just do hello world and then use the brackets. So that's how you call the function, and that's how it shows the result. Now, your function can be with a single argument. So for example, here we are passing in an argument called name, and we can then use this to pass a value to this. So here I'm saying hello name. I have my function, but this one takes a single argument, and we are going to use paste, which basically can concatenate or just adds up whatever you are passing in to paste. So we will say paste hello and then the name. Notice that I have given a space here after hello so that I can have it in the right format, and I can just do this. So the function is created, and now let's pass a name here and just try to call the function. So name is one argument or a single argument which is passed to this function. So let's look at the result, and that shows me the name whichever was passed to this one. Now what we can also have is function created which takes two arguments, and this is a simple example. So here we are creating a function add num. I'm saying function, it takes two argument. I'm not providing any value or default values for this. We'll see some other examples for those. Now here this particular function takes two arguments, and whatever you pass in here, a addition of that will be seen. So let's create this function and let's call it and test it, and that shows me the result as 70. Now what we can also do is we can add a vector to a number. So vector is list of elements or list of objects, you can say, and here we would want to perform add num, or we would have to call add num function by passing in vector, which becomes the first argument and the second value is the next argument. So let's run this one, and that shows me the result wherein 5 as a value has been added to every element of this particular vector. Now when it comes to function, you can also have default argument values which can be passed. So here let's look at as an example. So we have hello name again, but this time instead of passing in just an argument, we will also provide it a value, or you could say that could be considered as a default value. Now when we create this function, we are doing the same thing as previous examples, but we are passing in an argument, and that argument has a value. Now once I do this, I can surely call this function without passing in a value, and that shows me the name which we had assigned to the argument, or we can even pass in a new name which will be assigned to name. So if we do this, it works in both the ways fine. So this is in one way you are passing in a default value, and then basically you can either call the argument or you can assign it a new value. So if we would do something like this, hello name, and then for example I would say name equals say Jerry, and if I would do this, so that also works fine. However, since we are passing in an argument, we are assigning a value, so either we can let it go for the default, or we can just pass in the value, or we can be very specific in mentioning the argument and then the value for it. Now how do we return value from a function? Let's look at this. So here we are creating a function, we are calling it full name, and this one takes name wherein we are giving Sachin, and title is say Tendulkar, and what we would do is we would use a return statement here. So return would basically use the paste function. It will take the values of name and title and then glue them together. However, we are using also a space so that there is a space between these two values to the arguments which are passed. Now if I run this function, my function is created. Now we have already passed named arguments, or we have already passed value to those. So we can straight away say just call the function, and that does whatever you have mentioned in the function body. I could have also said that I could create a new one wherein I will pass new set of values, which we saw in a previous example. And then if we call this, it takes up the new values. So either you can let it go for default, like what we did here. We can also pass in new values, or if you would want to keep it specific, you could basically say full underscore name. That's my function. I could say name equals, and I can say John, and then I will say title Smith, and that's also fine. So we can do this, and that works in the same way as it would have worked with just passing in the names. So this is fine. And if you would want to test it out, say for example, if I would just take off name here and just do this, that also works perfectly fine, wherein we are still using these arguments in the particular order. Now, if I would have changed this one to name, wherein I am already passing in a value for name, and if I tried this, so in this case, what happens is name is Smith, and basically your title becomes John, right? So we have to remember what arguments we are passing, and if we are basically assigning values to the arguments or letting it pick up the default ones. So let's do this, and that looks okay. Now, when you talk about scope of a variable, okay, now before we understand scope of a variable, let me show you some more examples on function. Now, say for example, if you were using built-in functions, we have lots and lots of built-in functions which are available for programmers, which they can use in their data science activities or data processing or computation. Now here we are using a function called rnorm to generate 1,000 random values from a normal distribution of mean 0 and 1. So I would use the rnorm, that's an inbuilt function, and I will call this, say, normal distribution. So that is already done. Now we can find out the mean on these random values which would have been generated using the inbuilt mean function, and that works perfectly fine. You can also create a histogram out of this, and if I do this, it shows me the histogram. So let's see the histogram here. Let's bring it out, and that shows me the histogram of normal distribution. If you would be interested in knowing about a particular inbuilt function, you can just do a question mark and use the function, and that basically shows you the documentation of the function. So this is a generic function which computes a histogram of a given data value, and here it takes arguments. So this is basically your data. This could be the number of arguments which you are passing in for your histogram to be created. Now we can look at some more examples here. So I can say to histogram with large number of interval breaks, and this is where I'm also specifying breaks and passing in a value. So this allows me to provide arguments to functions by position. Now the same example which we have given here, we can do it without breaks argument, but as a good practice, we should actually give name to the arguments which we are defining. So if I would do this, wherein I'm passing in my data, that is normal distribution, and then for breaks, I'm just giving the value 50, and that is also fine. It works perfectly fine here. Now we can create our own function, which, as we saw in some basic examples, functions which can be without arguments. Say this is a simple example, or with arguments. So this one, we have already seen how you can create a function without giving any argument, or by giving an argument and then basically calling in the function. Now, when it comes to optional arguments, so we can look at this function wherein I would want to say find out the exponential value of a particular number. So I call it expo value. I use my function. I say this will take the value x. Now that's an argument which we are passing in. We could have given it a value, or we will just let the user provide the value when this function is being called. I will also give a default argument, which is power equals to, and here we would want to get a histogram of the values with a particular power. So if I create this particular function, that's done. And now I will just pass in my value. I don't need to mention power. That has been given a default value. Yeah, if we would want to change it, then we can pass in that. So let's run this one, and that gives me exponential value, a histogram based on the normal distribution data, and by default it is using power as 2. Now what we could have also done is we could have specifically mentioned a different value for power, and that works perfectly fine. I could have just passed in the value as power, and that also works fine. So here you are using named arguments and basically passing in any other arguments. Now what we can also do is we can use these named arguments, and then we can also do, or we can pass these arguments. That is what we call as passing any other arguments. Now if you look at the explanation of this histogram function, if we look at this, it shows me these 3 dots, and this is what we can use to pass in any other arguments. So let's look at an example for this one. So say for example, I would want to create a function where I am passing named arguments. I am passing in the data, but then I would also want to pass any other arguments which can be passed dynamically. Now for that, we can create a function here wherein I'm calling it expo value again. I'm passing in my x, which will be the data which we'll pass in. You are mentioning power, which is 2, which is a named argument, which can also be considered as a default, or you can change the value, or you can provide a new value. And then I'm also giving these 3 dots, which are also passed in within this particular function. So let me create this function here. Now once that is done, then I can call this function by passing in my data, which is normal distribution, power is 2, and then I'm also using these breaks for getting my histogram with intervals of 50. So let's call this function, and that gives me the histogram. Now what we can also do is sometimes it might be useful to pass logical arguments. So for logical arguments, what we can do is we can create a function which will take the data. Here I'm using a named argument exp, that is for exponential. I'm saying if the value of histogram is false, and then I'm also giving any other arguments. So what we'll do here is in this function, we will say if the value of hist is true, then this block of code will get executed where you will get a histogram based on the exponential which has been assigned in the function passed as an argument. And if that doesn't hold true, which is by default false as we have given in our function, then this piece of code will get executed. So let's create this function, and that's done. And now we can straight away just pass in our data. Exponential value is given as 2. Histogram has been given in false. That means the else part of the code will get executed. And we can look at the values here. I can also say histogram is true, and that's where we will be calling in the hist function, and I can do this. That shows me the histogram. So in this way, we can pass in named arguments, we can pass logicals, and then we can also pass any other arguments for our use case. Now looking further in functions, let's also understand the scope of a variable in a function. So here I am saying v, and then I'm saying I am global variable. Let's create this. And then I'm saying stuff. So I'm global stuff. So this is basically, we have assigned some values to variables v and stuff. Now let's create a function where I'll say fun. I'll use the function, and I will say this will take my variable stuff. I'm saying print v, and then for stuff, I'm assigning in a new value, and then I'll print stuff. So let me create this function and let's see how it works. So if, for example, I would just say print v, that shows me the global variable which we had created earlier. And since I'm using that within my function, it basically has the value. Now I also have a global stuff. So I'm saying print stuff, and that shows me whatever was assigned to the variable. And now we will basically call the function by giving in the argument as stuff, the variable which we had created. Now, if we do this, then it says reassigning stuff inside the function. And that's because within the function, we are basically assigning a new value to this stuff. Now, I can also just do a print stuff now. If you see, it still goes back and prints the global variable. So only within the function, reassignment happened. And that's what we understand when we talk about global variable or local variable. Now, to create a function to find the final amount to be paid by a customer after adding 20% tax to the purchased amount. How do we do that? So I'm here creating a function which will take x as 100. And what does that function do? We would want to basically find out the amount which is paid by customer after adding 20% of tax. Now, how do we calculate that? So we take x plus 20% of x, and that would be the final amount which will be paid. So we do a return t, and this is my function. So let's create this function, and then let's pass in a value to see what is the amount which customer would pay with an addition of 20% tax. So this is a simple function where we are passing in one argument, we are giving it a value, and then we are doing computation within the function body. What we can also do is we can create a function where I am passing in an argument, and I can then check the value of that. So if the argument passed was greater than 0, then we would find out the final amount, which is amount plus 20% of the amount. If the amount is less than or equal to amount, then equal to 0, then our final amount is equal to amount, and we return f amount. So here we will be evaluating these conditions, and based on that my function will return the value. So let's create this function and pass in a value, and that shows me 100. So you can just test this by saying amount 1, and say for example I would have passed in 0. Now in this case my final amount is 0 because there is no amount which needs to be paid by the customer. Now checking the argument and the body of a function. So we can always use this inbuilt function args, which will tell me for this particular function what are the arguments and what is the body of the argument, which basically tells me whatever we have coded within the function body. Now to understand the scope, we can create a function here which is taking an argument x, and what does this do? So we assign a value to y, then we basically say g1, and here I am using function of x. Now what does that function of x do? So this one will take the value of y plus multiply x by itself. So this is a function which we are creating, and then I am saying g1 of x. So what you're doing is whatever value was passed in as x, for that function x will be applied. So let's create this function and then pass in a value 10, and that gives me the result as 110. Similarly, we can create another function where we want to do some computation, and then I'm creating one more variable which has basically the function, pass in a value for y, and then basically what you do is you are calling in your g2 function, and then let's call in this function. So let's do this, and let's also create f2, and then finally we will call in f2, which is internally calling g2. So these are some simple examples where you are doing some computations and creating some simple functions. Let's also create a function which is taking 2 arguments. So here I have G2. Function takes 2 arguments, x and y. What does that function do? Here we are saying y plus x into x. That's my G2. And similarly, I'll create F2, which is going to have a value assigned to y. And this one is going to call in my G2 function, which will take x and y, x which we are passing in here, and y which we have assigned. So let's create this, and then let's call our F2. And what does that F2 do? It basically has the value of y assigned, and then it does whatever is mentioned in G2 with our x and y values. So I'm passing in 10 here. So it is basically y, which is 10, plus you have the x value, which has been passed here. So let's look at the calculation, which is 10. So that gives me 110. So 10 into 10 into 10 plus the value of y. So this is how we can create functions which have been assigned some values and then pass in some other values to those. Look at some more examples here when we work with functions, and see how we can use functions to carry out our basic operations or calculations. So for example, here I'm creating a function, and this will take an argument wherein we are saying it would be marks. Now let's do this, and the function body would say result is not defined. Now if the marks are greater than 50, then result will be pass, and you will have the message which is your result is, and then you are passing in the value of result. So let's look at this one. So let's create this function, pretty simple function, and then let's pass in a value here. So I'll say status as 60, which will be checked for the value greater than marks or lesser than marks, and that tells me your result is pass. And if we give this one, then it says your result is not defined. However, we can have additional statements here which can say if the result was lesser than 50, then what should have been printed. This is a simple example. Let's look at one more example. And here my argument is age. Now just notice that we are not passing any default values, or we are not passing any values to the arguments. We are just passing in an argument which will be assigned a value when you call the function. Now here we say age group is not defined, we say vote is not defined, and then we start using some condition checks. So I say if the age passed is greater than 18, then the age group would be adult and the person can vote, and message your age group is and voting status is will be printed out. So we can use this, or from our previous learning we can do a if else and modify the function. So let's create this function and then pass in a simple value to this, and that tells me what is your age group and what is your status to vote. So now if we would want to create a function to convert a name into uppercase, let's see how we can do that. So we are creating a function here which takes the value name. Now then we also find out the length of this particular argument, and for that we are using an inbuilt function called n characters, which will be for your name, and you would want to find out the length of this particular name. And we would say if the length is greater than 5, then we are again using an inbuilt function called toUpper, which will convert the argument or the name passed to uppercase. We will say message user given name is, and then you print out your name. So let's call in this function. So let me first create this, and then I can call in this function, and we clearly see that the number of characters in this word is more than 5, and that's why it is converted to uppercase. However, if you would call the function with a name which has less than 5 characters, it says as it is. Now this is again a simple function which we created. Let's see how you can create a function to calculate bonus. Now here we are passing in two arguments. So this function takes two arguments. One is salary and one is experience. And then we say if the experience is greater than 5, then bonus percentage will be 10, and else bonus percentage will be 5. And here we will calculate the bonus. So first it will find out how many years of experience a particular employee has, and based on that, a value of bonus will be assigned or bonus percentage will be assigned. And then you say what will be the bonus, that is salary into the bonus percentage, and return the bonus amount. So this is a simple function. Let's basically select this and let's create this function, and then let's calculate the function if the salary is 25,000 and experience is 6 years, and that basically will tell me the value. So let's look at the value. It tells me 2,500, which is 10% of the salary. Similarly, if we go for this one, which will basically go for the execution of else part of the code, we can do this, and that gives me bonuses half of it. Now, how do we handle multiple conditions and multiple actions? So let's look at that. So let's create a function which takes one argument, which is age. We would check if the age is greater than 0. Then we would want a nested if within this condition. So if age is greater than 0, then whatever we have given here will get executed. And this will be this part of your code. And here I'm again checking if age is less than 18, then age group would be kids, else if. Now else if is to check the second condition. So if the age was passed, if it is greater than 0, then we get into this block of the code. Now it was greater than 0, but then is it less than 18? Then I would categorize the person as kids. If age is less than 60, then we will say age group adult, else we will say age group senior. Now we can basically say that we could have given more conditions to this, because here we are saying if age group is less than 18, then the individual would be within the age group of kids. If that is not true, that is it's not less than 18, so probably it is 18 or greater than 18, then we are checking the second condition. If the age is less than 60, age group is adult, and if these two conditions are not met, then it jumps to else, where age group is senior. And if this whole block was ignored because age was less than 0, then we would have just printed out age group is not defined, message is wrong age, and your age is such and such. So this is our whole function. So let's go ahead and run this. Now let's check the age group when the age is 10, when the age is 40, when the age is 65, or when the age is minus 10, which is not defined. Now there are some inbuilt functions which can be used in R, such as your switch function. So looking at this function, that is switch function, we can see, or we can use this for our different kind of operations. So here your switch function returns values match with the first argument, and first argument should be a character. Let's have a look at the example. So say for example you want to return the house rent allowance or HRA amount based on cities. So we create a function called HRA. Now that takes an argument which is city name, and here we will say what does this function do. So here I am saying HRA amount, and I'm going to use the switch function. Now switch function, I'm saying I would want to convert the city name to uppercase so that we can maintain some consistency. And here I'm saying if the city is Bangalore, it would be 7,500. If it is Mumbai, 1,000. If it is Delhi, 8,000. Chennai, 7,500. And you have 5,000 value. And you are returning the HRA amount. Now, what do we do with that? So let's create this function. It's done. And now we will pass in the value. So we will see whatever value has been passed to this, and that gives me the value here, right? So switch is basically taking me directly to this value. Now, however, if I try to provide a city name which is not given in the list, so when I'm saying, say for example, Pune, now what is happening is it is just taking a value which has not been assigned to any of these conditions. If I go for again something else which is in a lower case, now this is where your to upper function will come into use. And if we do this, it basically converts this into uppercase Bangalore, and then basically it gives you the value. So this is the usage of a switch function. Let's look at one more example. So for example, here we are creating a salary range, which will take an argument, which will be band. And I will say, these are my bands, or you can say these are my options. So I can say L1 is basically 10,000 to 15,000. L2 is so and so, and L3 is so and so, and you return the range. Now let's create this function. Sometimes you have to do it this way. So our function is created, and now we can just do a salary range given a value, and that gives me the range of the values. However, if you pass something which is not mentioned, then it basically prints out null. So in R, you can also use repeat, which can be useful. And what does repeat do? So here I am assigning a value to a variable called time. Let's do that. And then I'm giving a piece of code with repeat. Now what does repeat do? So you're passing in a message which is hello, welcome to our tutorial. And then you're saying if time is greater than or equal to 20, you would want to break out from this loop. And then you also increment the times value. And this will keep repeating till this if condition is met, wherein we have said time value starts from 15. So let's do this. And this basically will print out the message wherein first my time was 15, which was less than 20. So you increment it, it becomes 16, you print it again, 17, print it again, 18, print it again, 19 and 20. And as soon as you reach the times value, which is 20, it breaks out of this and it stops printing this particular message. Okay, now let's look at some more examples. So if you say R, we will use, say, a function to find the square of any given user number. Okay, if the square value is less than 100, then increment user value by 1 and find square again, and repeat this till square exceeds 100. Pretty simple. So you create a function which takes n as an argument, and you would want to repeat it. So you would want to repeat this by squaring the numbers until the square exceeds 100. And once it reaches 100, you will break out. So this is what we are doing, and we are auto incrementing or incrementing the value of n by 1 every time we calculate a square, and then you return the value of n. So let's create this function, and now let's calculate it for square 6, and that tells me what is the square. Now as soon as your square value touches 100, it basically breaks out of the loop. Now, if you would want to find balance in a bank account after n years, if a person has deposited X amount in the beginning and bank gives a interest of 8% per annum, right? This is a simple calculation. So it needs the amount which was deposited, you need the year, and you need the rate. Now, year, which is n years, can be given by the user. Rate, we have already given 8%. However, functions main functionality is that you can even assign new values to it. Say later, 1 month down the line, the bank rate changes, might be it increases, might be it decreases, then function should not be modified. It can just take up the new values and start calculating from there on. Now here we will say get the final balance. Function takes amount, the amount which would be deposited. Year, And that could be, say, 4 years or 5 years or 10 years, for which you would want to calculate the rate of interest and add it to the amount. So I'll say for I in 1 to year. So that depends on how many times you would want to run this loop. I would say interest would be using the round function. I'm saying amount into rate, whatever is the rate of interest. And then you are giving 2 years. Now, final amount will be calculated. So you are basically saying amount plus interest, and you will pass in a message where we'll say year is the value of I, that's first year or second year. Amount, what is the amount? What is the interest you are calculating based on the round function? And final amount will be amount plus the interest. And then you basically say amount will be given, or final amount will be assigned to amount. Now, if this is a function, you would want to return the final amount. So let's just select this and then basically create a function. And let's say I would want the final balance. If the amount deposited was 5,000, it was kept in the bank for 5 years and rate of interest was 8. Now that should basically give me my final amount. And if we double that, so we say amount is 10,000, number of years is 10, but the rate of interest is less. So let's calculate this, and that gives me the interest. However, if you notice, based on my message, it is basically telling me what was the first amount, what was the interest, what was the final amount. And it does that for all these number of years. So these are some simple examples for your functions, right? Now we can also look at, on the similar lines, we can create some interesting functions. So you can find the total number of years required to raise $1,000 if the user deposits $750 per month. So here you're not actually calculating the final amount, but you would want to find out how many years are required to basically have the amount as 8,000. So your function, we are saying the amount is, say, 550 or say 750 per month. Now I would say let the final amount be 0 as of now, month is 0, and I will say while my final amount is less than or equal to 8,000, I would want to do something, and that is you are incrementing the value of month by 1, because that's your first time your amount is less than 8,000, whatever deposit was made, say $750 per month. And then you have final amount, which is your initial amount, which has been assigned to F amount, that is 0, plus the amount. You print out the message, and then you basically say year is whatever value was passed for month. So you may want to have it for number of years or years with particular amount of month. So we will calculate the year value. Now here what we are doing is we are calling in this required years function without an argument, which takes the default argument, or you can pass it with 750. We can run this. So let's create this function. Pretty simple. Done. And if we do not pass an argument, then the amount is 750, and it tells me what would be or how much time it would take for us to reach from, say, 750 or 550 to final amount. Similarly, if I would have done this, it tells me again a new value. So we are finding out the total number of years required to raise 1,000 or raise the amount to $1,800. So these are some simple examples of functions which you can use for your operations, your calculations, and also creating functions which can be repeatedly used with either one, either no, or either multiple arguments. Now, so far we were learning on creating our own functions, and we also looked at using some inbuilt functions, either creating a plot or basically doing some basic operations or passing in multiple arguments. So let's look at some more examples. And when we talk about built-in functions, there are lots and lots of built-in functions which are available in R, which can be used. So let's look at these. So for example, here are some built-in functions which can allow you to work with different data structures. For example, you have a sequence function